Hey folks, I'm Mr. Hartzler, and I want to talk to you about series and parallel circuits, and we're going to do that through this PowerPoint. So I'm going to start working through this, and we'll learn stuff as we go. So here we're going to be calculating the total resistance for, and then they list 3 different sizes of resistors, and they're all connected in series, and series does make a big difference. So let's get started on this one. Because it is series, that means that I'm going to use this specific formula. So RT, or my total resistance, is going to just be the sum of all of my resistances. So the sum of resistance 1, some with resistance 2, with resistance 3, and so on. But in this case, we just have the 3. So my total resistance is going to be just adding them all up, making sure that all of the units are the same, because we have 50 or 650 ohms, but sometimes I'll throw in like milliohms or kilo ohms, and you don't want to mess all of that up, because technically 1,000 ohms is 1 kilo ohm, and you might just add 1, and that'll throw you all off. So be mindful of your units, and be graceful when it comes to my symbols in here, because some of these symbols get pretty tricky in electrical stuff. So we have all of this, and then we add them all up, and let's see, we get I'm actually going to write these on top of each other because I don't have a calculator with me, and it seems usually easier to do it like this. 0002, 2000, I believe. Awesome. 2000 ohms or 2 kilo ohms. All right, folks, let's get started on the next one. All right, so now we're calculating 10 120 ohm resistors in series. So if I have 10 of them, and we're still in a series, so that means our total just equals the sum of all of them, right? But I also know that they're all the same. So I know that I have 10 of the exact same resistor. We'll just call it R1 here. So that means I have 10 times 120 ohm resistors. Well, that's pretty easy, right? That's 120 with an extra 0 because of that 10. And that's regular ohms, or 1.2 kilo ohms. All right, folks, we're looking good. Let's keep going. A string of 50 15 ohm resistors, or sorry, Christmas tree lights, are connected in series. One burns out, they all burn out. Calculate the total resistance. And that is very true. If one does go out, they all go out in a series, because they all have to continue in order for it to work. Otherwise, the circuit is broken. All right, I have 50, so this one's going to be set up very similar to the last one. 50 times the 15 ohm resistor. Well, 15 times 50. So resistance total is going to be 750 ohms. Awesome. We'll just keep on moving. All right, folks. So we have 3 1.2 ohm lamps that are connected in series. That's the nicer one, and connected to a 3-volt battery. Calculate the current in the circuit. So let's first find our total resistance. I'm erasing instead of writing here. Our 3 times 1.2, because they're all being added up because they are in a series. That's the nice one where they keep going like this. Do, squiggly, 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 all the way over to our battery. All right. So all of that ends up being 3.6 ohms for my resistance total. I am now connected to a 3-volt battery. Calculate the current. So that's V equals I times R. My voltage is 3. I don't know my current, but I know my resistance is 3.6 ohms. So I'm going to divide now by 3.6. Divide by 3.6. And that calculator math will tell me what my current is. Ready for it? That ends up being 0.833. And then the 3 repeats, but I'm not going to worry about that so much, because again, engineering, we don't really care about that stuff. Equals my current, and I should actually put my little my amps in there. So that's amps, and I'm going to write that equals I. So that could also be 833 milliamps, in case you're curious. Let's go on to the next one now, shall we? All right, so on this one, we're going to identify what the voltage drop is across each of these lamps. There's 3 lamps, and it didn't actually give me a resistance, which I needed. So I stole that from the last problem. Like, we're going to call it 1.2 ohms of resistance per lamp. First thing I need to do actually is find the total voltage or total current that's going to be going through this thing. So we need to find our total, which is going to be 3 times the 1.2 ohms that each of those lamps have. So my R total ends up being 3.6 ohms. Now I need to find my current total. I'm going to put IT here. But that's going to come from my V equals I times R. So my total voltage is 6. My current, well, I don't know that yet, so I'm going to write that down. And then my total resistance, all of these are totals, is going to be that 3.6 ohms. I'm going to divide by the 3.6, and I get 1.7, rounded up a little bit, for my, not voltage, this is going to be my current, so amplitude, or amp, and that is my total current. I'm now going to use that number to find my voltage drop across each one of these things. So now I'm using V, my voltage across 1, equals my current at 1 times my resistance at 1. So my my current here is 1.7 amps. My resistance at that particular lamp is 1.2 ohms. Multiplying those two things, and I end up with 2. And that's going to be then volts. 2 volts is what's going to be across each of those. You'll also notice, so for my voltage across 1 plus voltage across 2 plus voltage across 3 should add up to be my total voltage, which it will, because each one is equal to 2 volts for each of these. Man, I cannot write today. So 2 for each of those, they add up to my total of 6. Awesome, we know we're good.